Hi, so today we're going to talk a little bit about convex and concave lenses. So similar to mirrors, the convex is the one that goes outside, and as many people use for their memory trick, concave caves inside, so it goes like this. And so now we're talking about lenses. So unlike mirrors, lenses do not reflect. They allow the light to actually pass through. They actually cause the light to refract. So this refraction causes the light to bend. With concave lenses, the lenses, once again, they actually go on the inside. So you'll see on all three of these, they bend on the inside. This causes the light rays to diverge. Let's take a look at this in more detail. So if we take this example right here, let's pretend there's a person, and this person is taking a look through a concave lens. Let's draw this apple over here. And as he's viewing this apple through the concave lens, you'll see the light rays are entering his eyes. They are diverging. So what happens is there's these two rays and they're splitting up. Your eye tries to make a virtual image by seeing the focal point, so where these two lines connect behind the lens, and they create this small version of this apple. So you would actually see a smaller image than the original image. Now let's take a look at a convex lens. So in a convex lens, you would actually see them come out. So this lens is actually bending out towards the incoming ray. In a convex lens, the light rays tend to converge together. When you're close to the image will be magnified. If you're standing right at the focal point, the image gets very blurry, and when you're far away, the image flips upside down. Okay, let's take a look at this in more detail once again. So if I just take a snip out, this is your convex lens. So we have the same person just staring at this convex lens. From the other side is this apple. And so the light rays are traveling away from the apple into the convex lens. If you're close enough before the focal point, then you'll actually see the apple magnified. If you're standing right at the focal point, it gets very, very blurry. And then anything after the focal point, the apple would actually show up upside down. Okay, this allows us to move into our last outcome. So Light and Optics 3, investigate and explain the science of image formation and vision and interpret related technologies. So we're going to start with this idea of related technologies. So how is reflection and refraction used in optical devices? We're going to start talking about a couple of these optical devices. The first one that we're going to talk about is a refracting telescope. Refracting, as you should know, talks about lenses. So a refracting telescope uses lenses in order to focus the image. There's 2 lenses and 0 mirrors. So this is the first telescope that was made. You can see here there's a giant lens right at the front, as well as an eyepiece lens closer to the eye. Because there's a lens way up here, and once again this one is a convex lens, it's going to cause all the light to converge. So the light is coming together. Because you're viewing it past this focal point right here, that means the image that you see is going to be flipped upside down. So at this point, the image right here is going to be upside down by the time it gets to here. You're going to pass through a second convex lens, but because your eyeball is so close to the lens, it's not going to have time to flip upside down. So the image that you would see is actually going to be upside down. This lens here actually just helps to magnify it some more, so you get a little bit more of a magnification through the eyepiece. Okay, so let's summarize this up. The objective lens, which is this big one right here, causes the image to become smaller and inverted. But the eyepiece is actually what makes the image larger. So this is for magnification, the second one right here. But because you're viewing it so close to the eyeball, the image stays inverted. So it would be this upside down image of this tree. It's going to flip upside down, shrink, and then this one right here will just magnify it slightly. Okay, so let's take a look at this reflecting telescope. Reflecting means we're using mirrors at this point. Mirrors tend to be a lot cheaper than lenses, so those of you with glasses probably know this. So we use mirrors and a lens in order to focus the image. Because they're cheaper, we're able to build these in much larger sizes. Also, there's a limit to how big you can make lenses as well, not from a cost standpoint, but just in terms of physical construction. So these can help us to magnify very, very far away things. And so what we have is the light streaming in from both sides. It's going to hit this concave mirror. And so the concave mirror is going to cause the light to converge. And so because they're converging, that means once again your image is going to be upside down and smaller. It's going to hit this flat mirror, so a planar mirror right here, and then the two beams of light come down towards the eyepiece. So somewhere in that travel, it's going to go past the focal point. Once again, your image will become inverted. It's going to pass through this eyepiece, which means it will magnify slightly, but it won't be flipped back right side up. So everything is still upside down. This one we've already used, but a microscope. So a microscope uses lenses to focus the image. And so it has two lenses. Once again, your objective lens and the eyepiece. So kind of similar to your refracting telescope. The light source is underneath, and then it comes through the sample into the objective lens, which is a convex lens, causing the light to converge. And then because we're viewing it past the focal point, it's flipped upside down. So if you remember, anything that we moved on the stage to the left, you would actually see it in your eyes moving towards the right. Anything that you move to the right, you would actually see in your eyes moving towards the left. So everything gets flipped upside down. Once again, your eye is so close that you don't actually see this second flip right here. It will actually just stay flipped upside down from this flip right here. Your microscopes help to make the image larger and inverted due to this objective lens right here. And the eyepiece makes the first image even larger, still stays inverted. So if you can see here, your objective lens, your eyepiece. Okay, so the last device we're talking about is binoculars. And so in binoculars, we have objective lenses that make the image smaller and inverted. And there's also prisms. So if you look inside here, there's a couple different prisms inside. Each prism rotates the image 90 degrees, and they make the image right side up. So this is causing the image to flip 90 degrees 4 times, causing it to be right side up at the end. If you zoom into the inside, you can see there are 4 lenses. So you can see these eyepiece lenses over here, as well as your objective lens over here. And then for prisms, there's your 4 prisms right along here. So hopefully that helped you out. You need to make sure you know convex versus concave lenses. And then think about how that relates in terms of mirrors. So they work a little bit different compared to concave and convex mirrors. And then your optical devices, how are the lenses and the mirrors actually used in optical devices? All right, hopefully that helped. Let us know if you have any questions. Have a great day.